Okay, for this question here, um, how do I know whether or not a rational function has a horizontal asymptote of 0, or how do I know if it has horizontal asymptote of some other number, or if there's no horizontal asymptote? Well, what you want to think about when you're doing this, and this is what that video is supposed to show, was I'm trying to do this so I don't show people names here. That's what's happening. Um, Let me pause this video for a minute. So for this first one, what I want you to see that we call this, I call this, I know it's just not me. We call this a top-heavy function because um, here, let me get a pointer. Because the numerator has a larger degree than the denominator. So if I go way out to infinity here, let's go, well, I don't, I'll never, we can't get to infinity unless we Chuck Norris, right? But you see, as we're getting out further and further away, that wiggly stuff in the middle doesn't even show up. But what we're seeing is some kind of oblique line with a slope, certainly not a horizontal asymptote. So that's why we say there's no horizontal asymptote there, because the numerator is growing so much faster than the denominator. Okay, now for the next one, do you see how they have the same power? What's happening here? I typed what happened here? I didn't put the square down here. Okay, where we're seeing there way at infinity is we're just seeing the horizontal line here. Let me type in the line y equals 0. And actually, let me even get fancier than that, and we'll change this so the x and y, so the y range is between the domain, or the range, I said that right, is between -1 and +1. That'll show up a little better. Yeah, 1 will work because the y-intercept is 0. Okay. Okay. So there's no vertical asymptote. There's just something happened here at 0. But we see way out infinity. I mean, well, not at infinity, but you see how it settles down the horizontal line, y equals 1. So that's because this is the same power. Um, they're both growing at the same rate, so they'll cancel out. And so like 100 squared over 100 squared is 1. A million squared over a million squared is 1. Um, and so on and so forth. So that makes the horizontal asymptote y equals 1. That's why they say there's a horizontal asymptote. Now, where this goes, we're going to take this a little further. What if I have a 2 over 3? You see how that horizontal asymptote is the same as 2/3 here? Let's write y equals 2/3. Y equals 2 divided by 3. You see how that purple line is the same as the blue graph? So if it's the same power, the horizontal asymptote is the horizontal line that's formed by taking the ratio of the two leading coefficients, in this case 2/3. If this had been 5 over 4, well, 5 over 3, it's going to be the same as 5/3. Here, let's make this be 5/3. 5/3, see? What if this had been just 5 on top? Well, there we're off off this graph. If we scroll up, you see how it's happening at y equals 5. What if it had been 5 in the denominator and not in the top? Well, that would have been 1/5, and we can see that if I come down there, that's going to be the same as 1/5. Okay, so if it's the same power, it's going to have the ratio of the leading terms. What if it happens if it's a bottom heavy function? Well, the bottom's going to grow so much faster than the top that it, like, so 1 over a million squared is basically 0. That's what we're seeing with this graph, that it's y equals 0. So the horizontal asymptote is y equals 0 if it's a bottom heavy function. Okay, so where are you going to have to go with this? Well, let me pause this and I'll pull up the textbook here. I have that open. So this is on what page is it? Page 234 of the textbook. So this section, they're asking for a whole lot more than the horizontal asymptotes. They're asking to graph it. And if you haven't done these exercises, I would do them. They're worth your time. You've got the worked out answers for these odd numbers. I mean, you're going to want to be able to do this for calc. So you might as well get some practice now while we're learning it. Oh, what do you see? Top heavy, bottom heavy, or same power? I see same power, both x to the first. So the 3 doesn't matter, the 4 doesn't matter. The horizontal asymptote will be the line y equals 2. How about this one? Let me get a pointer going. Do you see how it's a bottom heavy? That would be x squared. If we forward that all out, it'd be x squared plus a bunch of other terms. Way out at negative infinity, positive infinity, the other terms don't matter. So that would be 4 over x squared, bottom heavy, y equals 0 will be the horizontal asymptote. How about this one? I hope you said same power because they're both x squared, right? So, and see how the 3 over 3 is the same number? So the horizontal asymptote wouldn't be 3, it'd be 1 because 3 divided by 3 is 1. How about this one? You're seeing same power. They both have a leading coefficient of 1, so y equals 1 is a horizontal asymptote here. How about this one? See how it's a top-heavy function, degree 2 over degree 1, so there'll be no horizontal asymptote. How about this one? Bottom heavy, so it's y equals 0 is a horizontal asymptote. How about this one when they FOIL it out for us? Well, if you did expand that top, you'd get x cubed plus some other stuff. If it expanded the bottom, you get x cubed plus some other stuff. And the other stuff doesn't matter when you're out at very large, really negative numbers or really positive numbers, negative infinity, positive infinity. So in this case, it'll be x cubed over x cubed. Y equals 1 is the horizontal asymptote. Okay. So I hope that helps. I mean, doing the rest of it, finding the y-intercept, plug in 0 into the function, you'll find y. The vertical asymptote, so where does the denominator equal 0? And we've talked about the horizontal asymptote, but then you just make a little sketch using that information. And you can check yourself with Desmos, but I'd really love you to, I need you to, your calculus teacher needs you to be able to think about that analytically without the tech, okay? Hope this helps. Give me a yell if you need some help, or come grab some time with me if you want some live help, question and answer.